Hello, geometry students. I'm glad that you're here. I know that right now you're working on assignment 47 because that was our lesson that we did yesterday, but a good number of you asked questions on 46, and I'm very happy that you did. So I'm going to shed some light on the ones that you asked. I'm going to do them in the order in the book because this is going to be a little bit easier this way. So please have your book open to page 355, 356 if you did have questions, because you're going to be looking at the drawings. I'm not going to be redrawing all of them, but just as we need to. So the first question is involving a circle that is surrounded by a triangle. And it says in there you're supposed to fill in the blanks. Since each side of triangle EGF is tangent to circle L, the circle is said to be, and the word that you're looking for in there, the circle is said to be inscribed. Inscribed. There's your word right there. Inscribed within the triangle, and triangle EFG is said to be circumscribed. And it's been a while since we had this. They kind of slipped this in as a review question, but circumscribed about the circle. So just that one was more of a review question. Question number 6 says to find GA if GD equals 23. So the simple answer to that is it's also 23. What you notice is that they are both tangents from the same point. So whenever you have anything that are both tangents from the same point, like this one, and let's do this one. Okay, so that would mean that the distance from here to here is the same as the distance from here to here. So that answer is 23 also. Another question, number 7, says to find LF. Find LF. I'm looking at the picture right now. If BL equals 6 and if BL equals 6 and if DF equals 9. So in order to do that problem, you have to recognize that you have a right triangle and that BL is the side of the right triangle, and it is the same distance as BF is the same as DF. BF is the same as DF, so that's also 9. So BL is 6 and BF is 9. And since you're finding LF, you need to use the Pythagorean theorem, a squared plus b squared equals c squared. And you're going to be plugging in the numbers 6 squared plus 9 squared and then finding out how much c is. Now on this particular help video, I'm not necessarily going to do all the problems. I just want to guide you into being able to figure them out. Remember, the odd answers are in the back, so you can check your answers back there. I would suggest that you do it, but if this was your question that you had trouble with, hopefully that's enough to guide you into finding the right answer. Once again, looking at this picture in your book, it says to find LG if LC is 8. LC is 8. Now that's a radius of the circle there. That would mean that LA would also have to be 8 in that picture. And AG is 14. And what you're noticing there is that AG is actually a tangent. So that means that AL would have to make a right angle. Remember, the lines that go from the right angle have to make a right angle. So once again, you're dealing with a right triangle if you draw in that line LG, and you're also dealing with a squared plus b squared equals c squared on that problem, and you would fill in and you would find out how much c is. You can give a decimal approximation for that. Question number 10, for those that need that, you're supposed to be finding the perimeter of triangle EFG. Now, as you look at the picture that's in front of you, it says that EB and GD both equal 4. So EB and GD both equaling 4 would mean that EA and AG both equal 4 for the same reason as this, because the distance from a point outside to the tangent point, they have to equal each other. So now you've got 4 and 4 and 4 and 4 as you go around. But then notice the F is out there to the right all by itself. And so if you look at FB, that has to be the same as FD. So to find the perimeter, remember, is the whole distance around. So for that one, you're going to take all of those numbers and add them up as you go around the triangle. 4 plus 4 plus 5 plus 5 plus 4 plus 4, and you'll get your perimeter answer that way. In question number 12, it's asking for the common external tangents in figure A and B. In figure A, it's just like the ones that we drew in the example problem. B and C would be your common external tangents. And you can check the notes for section 8.2 to see the pictures of those. And for part B for that question, the common external tangent would be line, I believe that's a lowercase l that they have there. And that's the thing that's a little bit different, might have thrown you off a little bit on that, is you've got a circle and then you've got another circle inside that circle. So I've got one circle, I've got another circle, and for them to be, they are actually tangent to each other. And then we have another line that comes across here. And so that spot that they meet, because this line is on the exterior, is the common exterior tangent on that one for number 12B. Skipping down to question 17, that was the next one that someone had asked about. Looking at question 17, what we can do here, a bright new sheet here for you. We are having a circle there, and they're asking you, first of all, to draw the tangent through that point. So if this is point P of the circle and you're supposed to draw in the tangent, what you need to do is you need to take a ruler and you need to draw, or even just sketch it in as best you can, so that you have a line that goes outside that hits at just one point, which is our definition of a tangent. And another one, it says there's a point X that's out here. For those of you that fuzzed out a little bit, we're on question, this was 17 that I was just talking about. Okay, that's this one where it goes through P. And question 18, they have a point X out here, and they wanted you to draw two tangents that go through point X. So if we start at point X, there's one of them because it hits the circle at one spot. And then in order to get the other one, you have to start again at point X and go out like that. And all of a sudden you've got the two tangent lines that they're asking for. That was question 18. Question 20 is asking for you to produce two circles having common internal tangents and two common external tangents. Well, that would simply be where you've got one circle and then you have another circle wherever they might be. Sorry about the extra dots that showed up there. And so your common external tangents would be going across the outside that way, and the common internal, the other common external tangent could go something like this. So it's touching just in one spot. And the internal tangents go between, remember? what we talked about last week, and then the other internal tangent would go in here. It doesn't say to draw them, but I'm just showing this again so you know common external tangents, common internal tangents. The internal ones go in between and the external ones are on the outside. Now that was question 20. Question 21 is saying to draw two circles having only one common internal tangent. So in order to draw a circle that would have only one common internal tangent, this one was 20, okay, 21, you would have to actually draw two circles that were right up against one another, okay, wherever they are, if they're left to right or top to bottom, whatever. So we've got one circle, I've got another circle. If these circles are actually touching each other, okay, this one, if you drew the common internal tangent, would be going right down in between, but there would be only one of them, and the external ones would go on the outside. So that would be for 21. Number 23 says two internally tangent circles, one having a radius that's half the length of the other one. Okay, I want to go back to what I was doing back here. I'm going to need that other picture shortly, so I want to get rid of some of this stuff. Let's cut that out here and go back to that question that I was just talking about. There we go. And on that one that I just was mentioning, number 23, two internally tangent circles, one having a radius that is half the other. Okay, so we have one circle. You have the center of that circle, and I'm just doing rough sketches here and just to get the idea. And so it says one has a radius that's half the length of the other. Well, the radius goes from here to here. So your circle that you would draw, in order to have half the radius, its diameter would have to be the radius of this one, so that when you put another dot in the center, right here, okay, the radius here then has to be half as much as the radius of the bigger circle, because here's the radius here, and then this one would be half as big. Two internally tangent, okay, that's the one I just had, and it also says it says to show the common tangent line and a line that is secant to only one of them. All right, so the common tangent would have to hit both circles at just one spot. Okay, there's not an external and an internal here, there's just one right here, boom. But then the other one said to show a line that is a secant to only one. Remember, a secant is a chord that kind of goes off. Oh, wow. I didn't realize I did that. Well, let's just come over here like that. So please excuse that. I'm going to move that one away. There we go. I had it on curvy instead of straight. Here's our common external tangent, or our common tangent that hits both of them. The secant line, if you'll remember, goes out here. It goes across. This one is secant to one of them, but it never touches the other, so therefore it's not a secant to the other one. All right. Then number 27 was the next one that someone asked about. And it said to find GH. Now this one's an interesting question in that I really think that, especially for someone who has not gone through Algebra 2, we can just kind of put that one on hold. But what I would like you to at least acknowledge on here, that this would be another Pythagorean theorem problem. A squared plus b squared equals c squared. And like I said, if you have not yet been through Algebra 2, you might not possess the skills needed to solve the quadratic. So what we're going to do with number 27 is say, when you take a look at it, you're trying, they're giving you EG that, and EH, the length of EH would be your A squared, the length of GH would be B squared, the length of EG would be C squared. They gave you enough information, but only if you have Algebra 2 behind you. So we're going to say, never mind on number 27 for now, because getting you up to that point takes probably several sections or a chapter. So we're going to just say thank you for asking about 27. Our takeaway is that it's a Pythagorean theorem question, but we're just not ready for that yet here. So I'll just let that one go. Let's get rid of this mess that I made here. I erase it. Okay, here we go. Because this one relates to question 31 that some of you asked. And question 31 is a little bit tricky, so I've got this here, but it's certainly solvable. It's like one of the examples that I did in class, but let's just see what we can do with this. I want to make this a really skinny little, here we go. Because this problem involves us putting in quite a few things. So we want to find AC. We're trying to find this distance. If we know that PQ is 39, I'm going to go ahead and draw in our 39. So 39 goes all the way from here to here. And we know that AP is 22. So we'll put in our 22 here. And we know that CQ is 12. Definitely not drawn to scale here. Okay, now here's the thing that we need to actually include right in this. We need to include, first of all, we know that these are right angles. Okay, that will be important in just a minute. So those are right angles. Because you're coming from the center of the circle and you've got tangent lines, these automatically have to be right angles. So that's one of our takeaways from this question. Another thing is that we can draw in a line, okay, and the reason I'm doing this is just to kind of show what's happening. If we draw in a line here that is parallel to this line over here, all of a sudden we're going to have a parallelogram that shows up in the middle of our picture. Well, why is that important? That's important because what I can do is I can take this 39 right here, and this 39, if you have a parallelogram, is the same as this 39 over here. Let me get my pencil a little bit bigger. So here, this one's 39 as well because this one's 39. This 12 can come over here, and if this is 12, this side over here has to be 10. And the reason that this side is 10 is because 10 plus 12 equals 22. We now have a little tiny right triangle here, and we're supposed to be finding this side, a squared plus 10 squared equals 39 squared. So we'll finish this one off. A squared plus 100 equals, let's get my calculator going here. Now on these things you can use any calculator you want. You don't have to have a fancy one. You can use your phone one. Remember, this is all for you, so the more honest you can be about these things, the better off you're going to be, because you all want to learn this, and I know that you're a great class. 1421, and then A then would be the square root of 1421. So we get about equal to 37.7. We'll do approximately equal to 37.7. I believe it said on the problem, this is problem number 31, by the way. I believe that, yeah, it just said to find the number, so it's about that amount. So here we are with the solutions to the things that you have asked about. I believe that I got everything. I had answered 36 on yesterday's note, so hopefully you've got that. But right now we're just going to call this question and answer session over, and I'm going to get this posted up here for you. And I hope you're having an amazing, wonderful day and a lot of good success working on your assignment 37. And my dog says hi. Have a great and blessed day.